But it is when contemplating the immeasurably tiny moment at the beginning of our immeasurably vast cosmos that these units really come into their own. Because our universe is expanding, becoming less dense, and it has been for all its history. But as we travel back in time, the observable part of the universe shrinks and becomes more compact, until eventually we get to a time when everything within it was only a single Planck unit of time old, a single Planck length in diameter, and with all of our observable universe compacted into such a tiny space, the temperature of the whole cosmos sat squarely at Planck temperatures. It may come as little surprise to learn that this moment, 100 million trillion trillionths of a second after the beginning of time and space, is therefore known as the Planck era. And gravity. As Max Planck predicted at the end of the 19th century, the strong, weak, and electromagnetic forces can be quantized, represented and thought of as tiny individual parcels of interaction, similar to particles of matter. But gravity is different. With his general theory of relativity, Albert Einstein was responsible for overthrowing the classical mechanical definition of gravity. Instead, he conceptualized it as the curvature of space-time, a warping in the very fabric of reality. And the gravity-induced curvature of space-time is now recognized as a property inherent to the universe which affects all matter and energy within it. Therefore, during the Planck era, long before any of the conventional laws of nature held sway, it was gravity that was the first to manifest. Everything we know about the workings of gravity today is based on Einstein's successful theory, but that theory is only really tested and verified on larger scales. However, our entire observable universe was condensed into an area many trillion times smaller than a proton. Instead, the dynamics of the extremely tiny are governed by quantum mechanics. At scales small enough that we can consider the individual subatomic particles of matter, or the quantized messenger particles of force and energy, an entirely different set of rules holds sway.